Morning student, today we will discuss measurement of conductivity of ionic solution, lecture number 7, chapter number 3, electrochemistry. So how to measure the conductivity of ionic solution? Keep in mind ionic solution. So when we measure the conductivity of ionic solution, then we are facing the two problems. Problem number 1 is passing direct current, change the composition of a solution. Second is solution cannot be connected to the bridge like a metallic wire or other solid conductor. Suppose metallic wire or solid conductor is there, we can directly connect into bridge, but here solution is there. That means we are facing two problems. So what is the solution of these two problems? Passing direct current, change the composition of solution. That means obviously the alternate is what? Instead of DC current, we have to pass the AC current. That means the problem 1 is solved. Instead of DC current, pass AC current. Now, how to solve this problem? Connection of ionic solution with a bridge. That means this can be solved with the help of conductivity cell. That means new term here, conductivity cell. So which type of conductivity cell are there and how it works? There are various types of conductivity cell are available. From that, one of the simplest conductivity cell is given here. That means this is one type of tube in which electrolyte is filled from here. That means electrolyte solution whose conductivity is to be measured, it is filled in here. Now this contains two electrodes. This is one electrode and second one. These are the platinized platinum electrode. That is a platinum electrode on which a finely divided platinum black is coated. Now the distance between these two electrodes is taken as L. Distance between two electrodes is L, and the cross section area of these two platinum electrode is A. Now this is connected from here wire. Now this will be the connecting wire. So from that we can connect this conductivity cell with a bridge. That means when ionic solution is kept in a conductivity cell, that means we can say the resistance of the ionic solution, that means R. We know very well R proportional to L and inversely proportional to A. That means R equal to rho L by A. So when ionic solution is kept in this conductivity cell, that means this value of L, that means the distance between two electrodes, and the area of this platinum electrode is A. That means when we are measuring the resistance of this, then it will be equal to the resistance of ionic solution which is kept in a conductivity cell. Now here L and A is variable depending upon the types of conductivity cell. This value will be changes. So here L by A is defined as the cell constant. It is known as cell constant of conductivity cell. Different conductivity cell having a different value of cell constant because arrangement will be different. Now cell constant having symbol G star, so G star equal to L by A. Now what is the unit? Unit of a cell constant, obviously, suppose L is in meter, then it will be meter square. That means meter inverse. Otherwise, suppose centimeter, the value is taken in centimeter, then centimeter square, that means centimeter inverse. That means in short, unit is length inverse, and this meter inverse will be the SI unit of cell constant. So we can write based on this formula. This L by A is the cell constant. That means we can write R equal to. Otherwise, we can write like this, taking inverse. That means 1 upon R equal to 1 upon rho, then A by L. Now 1 upon R is known as the conductance, that means this is the conductivity, and shifting L by A from this side, that means L by A. That means we can write K equal to G into L by A. L by A means the cell constant. That means again we can write like this, K equal to 1 upon R into cell constant. Now, if you want to measure the conductivity of a solution, then how to measure? So, if we know the cell constant, that means the value of L and A, or given the conductivity cell. If we are measuring the L and A from this conductivity cell, but this value is not reliable, again measuring the value of L and A, error will be there. That means how to measure the cell constant. So for that, measuring the cell constant, we use the solution whose conductivity should be known at various concentration. By measuring the resistance of that solution, we can measure the cell constant. That means if we want to measure the cell constant of this conductivity cell, then use the solution whose conductivity is known. That means the value of K is known. Now measure the resistance. If the resistance is measured, conductivity is known, then soil constant will be obtained this conductivity cell. And once the cell constant is obtained, this conductivity cell can be used for the measuring of the conductivity of any solution. Now for that KCl solution is used, that is considered as the standard solution whose conductivity is known. Now measure the resistance, cell constant is obtained, and now use this conductivity cell for the measuring of conductivity of any solution. Now how the resistance can be measured? That means for measuring resistance, one experimental setup is like that. That means use of piston bridge. That means connect this conductivity cell. This will be suppose conductivity cell whose resistance we have to measure. That means R2 we have to measure. Like a setup is like this, here detector P is there, here variable resistance is there, like this. This will be the R1, this here variable resistance like this. This will be R1. Suppose this is R4 and this is R3. Now here R2, that means the conductivity cell, whose resistance to be measured. Conductivity cell. That means instead of ionic solution, we connected the conductivity cell from this wire. Easily it can be connected. Now instead of DC current, we have to use AC. That means this will be the AC source. That means the AC source. Now this is the experimental setup. This will be the detector. R3 and R2 is the known resistance. In a Wheatstone bridge, R1 is the variable resistance. And R2 is the resistance of this ionic solution which to be measured. R2 is the unknown resistance. Now we have to balance this bridge. That means R1 is the variable resistance. So by changing the value of R1, we have to balance this bridge. That means there should not be passed current from this detector. That means we have to put the value of R1 in such a way that there will be no current in a detector. That means the bridge is balanced. That means I equal to 0. When I becomes 0, that means there is no current pass through detector. At that time, this bridge is balanced. That means these two opposite resistance will be equal. That means R1, R4 is equal to R2, R3. Now R1 is a variable we have known now for making I equal to 0. That means only unknown is R2. That means R2 equal to R1, R4 and R3. Now this R2 resistance is calculated. Now once the resistance is measured, now we use this formula. Resistance is measured. Cell constant we know using the KCl solution for a given conductivity cell. We have already calculated the cell constant. That means cell constant is known. Resistance is calculated from here like this method, and conductivity is can calculate by using this formula. That means if we know the cell constant of the conductivity cell, measure the resistance and calculate the conductivity of ionic solution. This is the experimental. This is quite the old method. Nowadays, conductivity meter are there having just a small size, pen like size, smaller size, and which is kept in ionic solution, and it will measure the conductance or resistance very fast within 1 or 2 minutes, and they are also inexpensive. That means it is quite a long method and old method. So nowadays conductance or resistance can be measured by directly using the conductivity meter. Now when the electrolyte is dissolved in a solvent, that means a different electrolyte. Suppose a different electrolyte is dissolved in a fixed solvent, given solvent, suppose water at a given temperature, Even though the conductivity of a different electrolyte will be different, because ionic ions are produced will be different, the size of ions will be different. That means so many factors. That means we have to define the new terms, more reliable term, which is related with the concentration. That means which relate the conductivity with the concentration. That means here new term we are using, that is known as molar conductivity. Molar conductivity. Molar conductivity having a symbol lambda m. This is known as molar conductivity. Now, how it is related with the concentration? That is defined as K divided by C. This is by definition. This is molar conductivity. Now, this is the conductivity. This conductivity is in a Siemens meter inverse unit, and this will be the concentration which is using in mole per meter cube. That means meter minus 3. That means instead of liter, it will be in a meter cube. That means concentration in mole per meter cube, but generally we are taking concentration in mole per liter. Then we know very well 1 liter equal to 10 power minus 3 meter cube. That means when in a proper unit this is converted, then lambda n is equal to K into C into 1000. This is molar conductivity. In this unit of K is the Siemens meter inverse, C is in a mole per liter, and lambda and molar conductivity will be obtained Siemens meter square mole inverse. Suppose this conductivity will be in Siemens centimeter inverse, then we have to convert this meter cube into centimeter cube, unique consistency. Then we are obtaining by converting this into centimeter inverse, and again this mole per meter cube instead of mole per liter. Then finally we will get K into 1000 divided by C. This will be the formula in which K is in Siemens centimeter inverse, C will be in mole per liter, that means molarity, and this molar conductivity will obtain Siemens centimeter square mole inverse. This can be converted into each other like 1 Siemens meter square mole inverse equal to, Siemens means here also Siemens. Now meter can be converted into centimeter. That means 1 meter 10 power 2 centimeter. That means meter square is square. That means 10 power 4 Siemens centimeter square mole inverse. That means if the molar conductivity is given in a Siemens meter square mole inverse, then multiply by 10 power 4, then it will be converted into Siemens centimeter square mole inverse. To keep these three formula into mind, for calculation of molar conductivity. See the unit of conductivity. Siemens centimeter inverse. Then use this formula to calculate Siemens meter square mole inverse. Conductivity in Siemens centimeter inverse. Concentration in mole per liter. Generally, concentration is given in mole per liter. Molarity is given. To see the unit of K, Siemens meter inverse, then use this formula. Siemens centimeter inverse, then use this formula to calculate the molar conductivity, and by this relation you can convert into each other.